solving simultaneous equations where one of the equation is a nonlinear equation. You need to do this method every single time. Substitute this into that. But before we do that, they want us to just do a little kind of trick here without solving. Show that 1, 2 is a solution. Show that that coordinate is a solution. So all you want to show is that if I substitute in these values into both equations, it works. It satisfies the value. So that's just some substitution we have to do there to collect a little 2 marks before we do the actual thing. So you should know which equation is the linear equation, which equation is the nonlinear equation. X and y, substitute the point, this point, into the first equation. So anywhere I see x, I'll put 1. Anywhere I see y, I'll put 2. Just work out that and see if the left-hand side is equal to the right-hand side. It turns out that it is. So 5 is equal to 5. That's true. Let's check it for the next one. Substitute the same little point here. 1, 2, ting, ting, ting. True. It works for both equations. I substituted the point into both equations and I got that they work. That the left-hand side is equal to the right-hand side. So it means it's true. Or you could have do it in this way where you substitute just the x value and find for y, and that the y value turns out to be 2 in each case. Whatever. Once it's the same, 1, 2 is a solution since it satisfies both of the equations. This potong, my neighbor potong, will not shut up. So you'll just have to take backing in this video, right? Listen to the maths, but let the backing be the music in the background. Alright, so now the next part of the equation, next part of the question wants us to solve the equation. This is what we really come here to learn. This is why you click on the video to learn how to solve the simultaneous equation when one of them is nonlinear, right? So this is the nonlinear one because you're seeing x squared and x by y, all them fancy thing going and give a curve. And this is x plus y equals 3, that's the linear equation. So this is the step you want to do every time. Substitute the linear equation into the nonlinear equation. Establish which is which. From equation 2, which is the linear equation, I'm going to make y the subject of the formula because I'm about to do some major substitution. Substitute y equals 3 minus x in equation 1. So anywhere I see y, I'm going to put 3 minus x. So you understand? Linear into nonlinear. When I do that, I will get a nice little substitution line here. This has replaced the y from here. And now I'll break that down, and very likely you will get a quadratic equation. So you see this is a quadratic equation. Now a lot of people not too comfortable when they see the quadratic equations looking like this, with the negative sign in front of the x squared. So if you're not feeling that and you don't know how to factorize that, carry everything across here and you'll get a quadratic equation. X squared minus 6x plus 5, you'll work out and get the same answers. Alright, but I don't care about that. So at this point, here's something I want you to remember. It's critical. Use your calculator, plug in the values, and solve the quadratic equation using your calculator. That way you're sure you have the correct answers watching you, and you can verify it in the exam. You still need to show the working, but you at least spend 5 seconds and just get the correct answer one time. So you don't make that mistake, you don't slip up. If you don't know how to do it on your calculator, I have a video. Just look for it. How to solve a quadratic equation with calculator, CSEC thing. Alright, so rearrange, solve that quadratic equation. When we solve the quadratic equation, we are going to get x is equal to negative 5 and x is equal to 1. Now remember, we already got the x is equal to 1 value where x is 1 and y is 2. So we don't really care about this one too much. What we were looking at is this one. This one is brand new. That's like, whoa, we love that. Okay, so when you get the x values, you get 2x values. You notice that? When you get 2x values, you need to substitute them into the easy equation, the linear equation, to get the corresponding y values. And that's it. That's it. That's all you need to do. So, you substitute the negative 5 here, x equals negative 5, into equation 2, which is the linear equation. So anyway, I see x, I put negative 5, work out for y, and I get y equals 8. So that's the other solution. So the solutions are 1, 2, and the next solution is negative 5, 8. You solve that. So these are the steps that you want to use all the time. Substitute the linear equation into the nonlinear equation. Simplify that down into a quadratic equation, which you will solve. That usually gives you 2 answers for x. There is the rare case where you will get two answers for x being the same number. That could come. But you still get two answers for x, but they are the same number. That means it's a tangent. Alright, and then once you do that, substitute the values of x into the linear equation to get the corresponding y values. I want you to watch this video again. If you don't understand, watch it again and do. Let me see if I have a question here for you. Yeah. Yep, I do. So you want to do this question, solve the pair of simultaneous equations, and look at this little part they're asking us. Good luck with that. If you get the answer, write it in the comments and I'll let you know if you get through. Till then, look out for the next video where I use simultaneous equations in matrices and show you how to solve that.